Since Terrell earned good grades in school, he qualifies for the good student discount on his car insurance. His monthly payment without the discount is $85. If the discount is 20%, what will he pay each month? So we're looking for how much he'll pay each month. A discount decreases the amount that you're paying. And so when we have a discount, we have to, instead of what we did with tax, where we added the percent to the original, we have to take the percent that we have and we have to subtract it away. So I'm going to put this information in. And so the original before the discount was 85, and that is 100. And now a discount doesn't add to what you originally do, it subtracts. So I have the total 100% that I'm starting with, but I'm subtracting off 20%. So really how much I'm going to pay is 80% of what I used to pay. That goes above the 100. And what will he pay each month? That's what we're looking for. So I'm going to give that a variable of y. Now we're back to our basic proportion. And setting up the problem is really the hardest part of any of these percent changes, percent increase, percent decrease, all of our proportion problems. So we're going to have 100 y is equal to 80 times 85, which is 6,800. Yikes. I'm going to divide both sides by 100. I'm going to end up with y is equal to 68. What does that mean? That means that Terrell is going to pay $68 as opposed to the $85 he would have paid before the discount. If you get good grades, please let your parents know, because some insurance companies actually do this. And now we're going to get to the coup de grace, the pièce de résistance. We're going to take everything that we learned in the previous examples, we're going to put it all together. So we're going to actually have a discount, and then we're going to have taxes. And that's the important part to remember what's happening. You're going to take the amount that we have, you're going to discount it, and then we're going to take the new amount from the discount, we're going to add taxes. So we're going to discount, which means we're going to subtract. And then we're going to add taxes, unfortunately. Okay? And that's because it's taxes. And that's how we get to the actual price. So this is the process for doing a problem where you have a discount and tax. You discount the problem first, and then you find the price. So it's really doing two smaller proportions to figure out a big one. So we're starting out with $14.99. So our original is $14.99. And since we're discounting 12%, 100 minus 12, because that's what we do when we discount, it's going to give us 88%. And that's going to give us the new amount. And I'm going to give it a variable. Okay? And I'm actually going to give it a variable d to remind myself that this is the amount that I'm getting when I discount. So we're back to our proportion. We get 100d is equal to 88 times $14.99. And that gives us 1319.12, excuse me. I'm going to divide by 100. And so I'm going to get d is equal to 13.1912. Now I know for a fact that money only has two decimal places. But as a rule of thumb, when you're trying to calculate something and you're not finished with your calculation, you want to keep as many numbers as you can keep. Okay? You want to keep as many numbers as you can keep, and then you want to round your number at the very end of all of your calculations. So I'm going to keep all those numbers. Now I'm going to do in a different color. Now I'm going to do another proportion, but this time I'm going to add taxes to what I used to have. So that doesn't change anything. What I'm going to do is say I have a new original. My new original is 13.9112. That's going to be the 100. And I'm looking for the thing after taxes, so I'm going to put that as T. And now the percentage, well, I'm adding taxes to what I'm talking about. So I'm going to take 100, and I'm going to add the 6.25, and that'll give me 106.25. And so what I'm doing is I'm finding the final price after I add taxes and after I've already discounted my original. Now I have my proportion. I do the same exact thing. So I have 100t is equal to 106.25 times 13.1912. That's going to give me 1401.565. I'm going to divide by 100 on both sides to get rid of the number in front of the variable. And then I'm going to end up with 1401. And since it's 14,015, I'm going to round up so it's 1402. And so the amount that I'm actually going to pay for this is going to be $14.02. And the reason that it's less than the original is because I discounted 12%, and then I added 6.25%. Now, one of the common mistakes is just to say, well, if I'm discounting 12% and then I'm adding taxes that are 6.25%, I just subtract them and then just subtract 5.75%. And so some of the common mistake that some people would do is say, well, if I'm discounting at 12%, it's minus, and I'm adding 6.25, really what's happening is I am subtracting away 5.75%. Well, that actually doesn't work. And the reason it doesn't work is the reason I drew the boxes. If I start out with 100, and what I'm going to do with 100 is I'm going to discount 100 20%, and then I'm going to add taxes, and this amount of taxes is kind of crazy. Okay? The tax that I'm paying for this thing is 30%. Well, according to this, it should only end up being 10% more. Right? If I use the misconception. The problem is that doesn't work. If I take 100 and I discount it 20%, well, 20 out of 100 is 80. But I'm no longer dealing with 100. Now I'm dealing with 80. So when I add 30% of 80, well, 10% of 80 is 8. So 3 times 8 is 24. When I add that 24 to 80, I get 104. This is what I end up with when I do it the proper way. If I did it the wrong way, I would have ended up with 110, because I would have thought that all I'm really doing is adding 10. So I would have ended up with $110 as opposed to $104, which is not the case. And the reason is when I take my taxes in the second box, this is the tax box, when I add taxes to this, I'm adding taxes onto $80. I'm not adding taxes onto 100.